It's happening all around us here in New Jersey. The effects of climate change. From ravaging storms like Sandy, rising temperatures in our oceans, algae in our lakes, even vanishing bees. You have questions.
Why is this happening?
What can we do to stop this?
How does this affect
Is
us?
our planet dying?
What can we do to help?
We have answers. A panel of experts from across New Jersey join us live for an eye-opening conversation on climate change here in the Garden State. Your questions, our answers. Live from Montclair News Lab at the School of Communication and Media at Montclair State University. This is Focus Climate Change. Here's our host, Louis Biondolillo.
Good evening. Tonight, we have experts from all over the state to help us understand what we are facing here in New Jersey. We'll meet them in a minute. But first, let's take a look at what is at risk. Scientists say that the burning of fossil fuels is heating the atmosphere and causing the phenomenon known as global warming. It has produced things you see in Hollywood's hottest blockbusters.
Everybody down! We should not underestimate the impact of this storm, and we should not assume the predictions will be wrong.
These are things we see on the news from around the world and around the country. And tonight, we'll be showing you how it's happening right here in New Jersey. The Jersey Shore attracts 17 million people every single year and is home to an additional 1 million more. By the year 2100, places like Atlantic City and right here in Point Pleasant are expected to be underwater, only 81 years away. Experts say that without major policy changes, this will be irreversible. The Meadowlands, a strip of land in northern New Jersey, is also expected to see major issues due to climate change. MetLife Stadium and Newark Airport are expected to have frequent major floodings throughout the next several decades. According to researchers at Rutgers University, New Jersey as a whole is experiencing the warmest temperatures we've ever seen. In fact, 11 out of the 20 warmest years recorded for the Garden State have occurred this century. And record temperatures aren't the only thing we're seeing here in the Garden State. Storms like Hurricane Sandy and Irene are causing mass destruction to communities. Hurricane Sandy alone displaced 750,000 people. But all is not lost. Scientists recommend that governments and corporations commit to funding and adapting alternate energy sources, like wind turbines and solar panels. Individuals can do their part as well, by eliminating food waste, for example, and limiting carbon footprints. Climate change is a real problem. It's time now to talk about real solutions. Now that we've set the table, let's meet our guests. First, Dr. Timothy Hall, a senior research scientist at NASA. He's an expert on tropical cyclones, their relationship to climate, and the hazard they pose to coastal communities. Next, Scott Fallon, a climate reporter for NorthJersey.com and the Bergen Record, who has covered the environment since 2008. Many of his articles concentrate on the legacy of industrial pollution in New Jersey. Our next guest is Meg McGuire, founder of the site Delaware Currents, which looks at the health of the Delaware River and the cities that depend on it. And finally, Dr. David Robinson, the state climatologist for New Jersey and professor at Rutgers. He conducts research on a vast variety of weather events that occur throughout the state. Thank you all for being here tonight. Let's get started. So, something that we're seeing in New Jersey and across the world, frankly, is rising temperatures. Just a little background on that. Dr. Robinson, would you mind starting us off with that?
Well, we certainly are seeing temperatures rise globally. We have credible records back to the late 19th century across the globe. Here in New Jersey, they go back to the late 19th century as well. And we're seeing a continuation of warming, particularly in recent decades. It's really quite amazing. Since 1989, we've not had one month in any year be one of the top 5 coldest on record. December of 1989 was the last time.
Wow.
But since that time, we've had 45 months hit the top 5 for warmth. So it's essentially a shutout in the last almost essentially 30 years. So that's just one way of demonstrating how we've leaned towards the warming side. We're still going to have some cold weather. That's all part of the whole climate system and its natural variability. But overall, the warmth is swamping the cold.
Right, and Dr. Hall, Could you give some reasons why that we're seeing these warming temperatures, these rising temperatures?
Sure, and I'd like to add to what Dave said. He's right about the reliable records back to the 1800s, but I would even say, in addition to that, we've got indirect estimates of temperature globally and regionally that go back thousands of years. And there's more uncertainty, of course, than a direct thermometer reading, but they pretty well confirm that we're now sitting at the warmest time the Earth, in a globally average sense, has experienced for thousands of years, and possibly tens of thousands of years. But so you asked the question why, and it's clear from many different and distinct independent lines of reasoning that humans have a huge role in the warming, at least since the dawn of the industrial era, and especially in the last several decades that Dave mentioned. And the majority of that is due to carbon dioxide in the atmosphere. That's a fundamental byproduct of fossil fuel combustion.
Ms. McGuire, would you like to add to any of that?
Well, one of the things that I think is also interesting, we know about the warming. It's, people are now getting, hip to that particular problem. But I think the other thing that's really interesting is seasonality. Like our understanding of what the seasons are is going to start to change, and that's going to have a huge impact on our agricultural community. Yep. The agricultural community, probably due to congressional funding and all that sort of thing and lobbying, has been calcified to a certain interpretation of farming. Those large farms that use lots of fertilizer, they're going to be hit hard, and it might very well be that we'd be better off with more smaller farms that can respond to the idiosyncrasies of the coming changes. But that seasonality thing, that's going to be a big one.
Yeah, and another thing I'd add is that we've been talking about sort of seasonally average, globally average temperatures, or regionally New Jersey average. It's actually the thing that's really hard on agriculture, you mentioned, but also, sort of urban heat health issues is not so much the average temperature, but the extreme temperatures. Yes. And it's really kind of a fundamental feature of a system that has a mean and some distribution about the mean, that when you shift the mean a little bit, people say, well, a couple of 2 degrees, what does that mean, 2 degrees? Why am I worried about 2 degrees? But actually, when you shift the mean a little bit, you shift the chances of getting extreme events by factors of 2 or 3, depending on how far extreme you want to ask about. So if you shift the mean just a few degrees, you may double the chances of getting 5 days in a row above 95 degrees Fahrenheit or something. Yeah.
And the thing
that's that's the damaging, they're really extremes.
It has impacts on our agriculture, but it also has impacts on our power structure, the power system, not the political power structure, although probably that too. But if you start having these many days of very, very high temperature, the demand is going to make on our energy system is going to be extraordinary. And so how we deal with that and how we deal with the repercussions from that is going to be another big issue in the coming decades.
And Dave, New Jersey has seen a substantial rise in its temperature, one of the biggest of the lower 48. I believe it's 3 degrees in the last century or so. I know the Washington Post had a big story a few months ago that was about 3.6 degrees Fahrenheit in the last 100 years. What are you seeing, and what does that mean for New Jersey?
Yeah, I worked with the Post on that article for several months before it came out. And one thing that strikes me, this year we've had a few 1 or 2 extreme record daily high temperatures. We've had a couple more daily minimum temperatures. So you can't even just look at that. It's the persistence of the warmth that has been so remarkable. Our Septembers are very different than Septembers were several decades ago. You're still wearing your shorts well into the semester, as opposed to in the past. So it's oftentimes the persistence, and also, interestingly enough, the minimum temperatures are coming up faster than the maximum temperatures. So that makes our nights more uncomfortable in urban settings in the summer, for instance, which again goes to energy and farming concerns. But you have to be careful what you wish for too, because a farmer might say, well, it's going to be great. We're going to get earlier planting season, earlier springs. The fact is, it's still winter to our north, and if we warm up in March and the blossoms start coming out on the peach and the apple trees and you get a late season cold spell, zap, they're gone. So careful what you wish for when you look for an extended growing season.
And it's really funny when you look at how Mother Nature, for lack of a better word, has intermeshed all the gears, right? So I think most of the people around this table are familiar with the horseshoe crabs and the red knots, right? Horseshoe crabs come into the shores of the Delaware Bay to lay their eggs, and do the next generation, right? But at the same time, the red knots have this astronomical journey from down in South America. And one of their vital stops is the shores of the Delaware in order to feast on those eggs. But the cycle for the crabs is based on what they perceive of the ocean. The cycle for the birds is what they perceive in the air temperature. And so they could miss. So there's these, one of the things that's so remarkable about that is that it's very perceptible, it's very concrete. You think of all those horseshoe crabs and all those birds, and suddenly instead of being at the same time, they're different times. And that's repeated like on an order of magnitude everywhere when you look at the issues of climate change.
Yeah, the effect on wildlife has an effect on us, of course, and you see that in New Jersey, and particularly with insects, particularly with mosquitoes. You see a longer mosquito season in New Jersey, and it's getting incrementally longer. So in last year, New Jersey saw the most amount of West Nile cases. This year, we saw the earliest West Nile diagnosis in New Jersey. And a lot of that is because we are getting warmer.
I was also thinking of the
and wetter
winters not being as cold. I think there's an effect on the tick population too, right?
Yes.
If you don't get below a certain threshold in temperature for a long enough period, they don't die off, and you get this, enormous tick season.
That's a problem in the pinelands with the southern pine beetle, which is affected by extremely cold winter temperatures. And one thing we found in our office is the extreme winter minimum temperatures, the coldest it gets during the winter. Those temperatures are rising at a faster rate than the average minimum temperatures in winter. So you're not freeze drying these eggs and such of these pine beetles. So they're able, as you said, to winter over, and they're decimating our pinelands, this invasive species. So another example of that longer season and more moderate seasons that is having penning all kind of havoc.
Right, it seems to be playing to the benefit of the invasive species as opposed to the native species, because the native species are expecting the temperatures and the variabilities that we had 20 years ago.
Right.
Sure, and if you're getting invasive species from like Southeast Asia, where we've seen a number of these critters come from, well, they're going to adapt certainly to or want to adapt to a certainly warmer climate here in New Jersey.
If you want to turn around another way, just one more example from agriculture, our fruit industry, our peaches and apples I've referred to earlier, believe it or not, those trees need a certain number of hours during the winter of cold. It's called hardening. And if they don't get enough of that cold, then that particular genome, that genus of peach tree, say, is not going to survive in New Jersey. So our peach growers have to look to the future and say, well, if I'm going to replace these trees, do I take a cultivar from Virginia and plant it here, rather than one that was more native, if you will, to New Jersey? So these are the decisions, not the wheat farmers and the tomato growers are facing, but those who have perennial type of crops. They're facing these. So it's all these hidden connectivities and changes that you don't spend a lot of your day thinking about, but there are experts out there from the health fields, the agricultural fields, you name it, who are looking at this.
What kind of public health concerns does this bring up?
It certainly, as I said, West Nile, ticks, Lyme disease, there's certainly that. What we've seen up here in northern New Jersey, we saw two of our biggest recreational lakes this summer closed for almost the entirety of the summer for a harmful algae bloom. This is something that you do not want to come in contact with. And the New Jersey Department of Environmental Protection is pretty straightforward with this. This is a result of climate change. It's a result of a lot of other things, a lot of other factors, nutrients, over-fertilization, runoff, septics, building along, development alongside our lakes. But climate change is a real problem, a real threat to our lakes, and becomes a real threat to human health.
In terms of, I would say, and also just simply extreme urban heat events. I mean, especially in disadvantaged, economically disadvantaged communities. I mean,
That's a huge environmental justice issue. Yeah.
Exactly, and maybe power goes out, they can't afford air conditioning, and how long, especially elderly people or people who are not healthy, how long can they sit in an apartment that's 115 degrees?
Yeah, there's studies. I'm just starting a National Institute of Health project with some epidemiologist at Rutgers Health Institute, and we're looking nationally at this issue with medications that elderly folks take, and the impacts that has of excessive heat on hospital admissions and even worse conditions, death and illness. So, we're looking at a lot of this. This is a living laboratory, and we're conducting this uncontrolled experiment that is quite frightening.
Dr. Hall, I know you work a lot with satellite imagery. So how do we track climate change using satellite imagery?
There are many streams of data that go into our understanding of how the climate is changing. And yes, you're right, and some key ones come from satellites. And often the best way to observe the Earth is from being outside of it, looking down on it.
Right.
Sort of the forest through the trees kind of approach. So that's actually why NASA, in some sense historically, that's why NASA has a big role in climate change research, because it has expertise in developing satellite instruments and launching them and interpreting their data. So, for example, sea surface temperatures are something that can be measured from space. Actually, the wind speed at the surface of the ocean can be measured from space, a device called a scatterometer. The composition of the Earth's atmosphere, at least some of the key elements, not carbon dioxide as it turns out, but some of the key elements, other gases that are greenhouse gases or reactive gases, the composition of the atmosphere is changing. Those things can be measured by space using very carefully designed and clever instruments that take advantage of signals that these gases can emit.
So exactly, and we're taking a look at things from perspectives we couldn't have and places we haven't studied. When I'm not serving as state climatologist, I'm a polar scientist, and I've been looking at satellite imagery since the 70s.
The GRACE instrument measuring the decline of Greenland's ice sheet, absolutely.
And sea ice, the sea ice decline in the Arctic Ocean, something I was looking at satellite images decades ago, and I can't believe how much open water there is in the Arctic Ocean at the end of the summer season now. I never thought I'd see it in my lifetime, and I study the extent of snow cover over northern hemisphere lands, and we've been watching spring snow extent melt out earlier each successive decade since the satellite record began in the late 60s. So we're seeing things from a different perspective, and one that we could never have if we were just taking observations from where we live, right down.
And if I can jump in there on the Arctic, actually, that's a key point that you brought that up. And the fact that Arctic sea ice is melting and exposing the ocean surface beneath it points to something that people in the climate business call a feedback effect. And it exaggerates the warming that would happen otherwise. And here's the deal. The Arctic is a perfect example, because this sea ice is mostly white. So this radiation from the sun sees it and it's reflective. And if there's ice there, a lot of that radiation bounces back to space. But the water is dark, and that absorbs the heat. And so that further exacerbates the melting of the sea ice. And you get this sort of like this feedback effect where you're exposing more water, things get even warmer, the ice melts further, you expose still more water. And actually, this has a special name. It's called Arctic amplification in the trade. But and it actually, we try to tie this back to New Jersey for a minute, but Arctic amplification is changing the temperature difference between the Arctic and mid-latitudes and the tropical regions. And that temperature difference is what, on average, essentially drives weather in the mid-latitudes. It determines the tracks of winter storms. It determines the tracks of hurricanes. And if you play with that temperature difference, you seriously play with weather. You play with the frequency of extreme events. You play with, the trajectories that hurricanes take. And Hurricane Sandy, now bring it back to New Jersey, is a possible example of this. Because Hurricane Sandy took a really weird track. It was sort of skirting up the coast, heading back eastward out to sea as hurricanes often do, and then it took a sudden left-hand turn and slammed into coastal New Jersey. And when in any particular hurricane, you can talk about this blocking event or this particular set of meteorological conditions that caused that. But on average, there's good evidence that suggests that those types of meandering tracks that are more prone to jogging suddenly left and hitting North America are increasing in frequency, and that's in part due to this exposure of the Arctic water and warming up. So the thing is very complicated, and everything is tied together. And New Jersey is experiencing ramifications of that, as are other states as well, of course.
Absolutely. And I think that's one of the things you hit on here, at least tangentially, is the whole idea of the water supply. And that's something that I'm particularly interested in, because the Delaware River supplies, in its headwaters, half of New York City's water from the reservoirs in the Catskills, and then supplies water to Philadelphia, Trenton, Camden, Wilmington, and many other municipalities up and down the river. Luckily, for decades, the rain has been consistent and the snowmelt has been consistent, that people have been able to plan the use of water. But now that the snowmelt is getting variable and the storms get variable, then it gets harder and harder to plan for people's water supply. And in New Jersey, the Delaware reaches into New Jersey with the Delaware and Raritan Canal. And that's like 100 million gallons that's going into New Jersey in the Raritan Basin, but then goes directly from the Raritan into the ocean. So that's water that's no longer available to the Delaware River watershed. And I think that there could be water wars in the future as water becomes more scarce at certain times of the year. And we've already had instances when New Jersey took New York to court, settled in the Supreme Court to establish what the sort of flow parameters has to be. But all of that could get revisited as people start getting scarce water at certain times of the year.
So you mentioned water wars, and that's something that I've never heard of before. When do you think that water wars might continue?
Well, there is a certain amount of water wars that goes out in the West, because the Colorado has been human development has drained the Colorado, so the river, once it reached the Gulf of Mexico, is like this little tiny little thing. And there's no sense that anything like this is going to happen immediately, but one of the things that we have to do, as we expect decades of change with climate change, is to start anticipating it. So should New Jersey build more reservoirs to maybe capture that Delaware River water? Should, in fact, more of the states, because there's New York, Pennsylvania, New Jersey, and Delaware that surround the Delaware River, should more of the states in that neck of the woods create more reservoirs to be able to capture? Well, creating a reservoir is a big deal, costs lots of money, and they have to buy land. And most of the places where you need the reservoir, the land is very costly. And whether a particular town would want that to happen is another thing entirely. But this goes back to what you were saying. This multiplier, first, second, third, fourth effects that are happening, that will be happening, that we can't predict in quite the way that we think we can.
Dr. Robinson, what do you think about this?
Well, I'm very much concerned with the availability of fresh water. As you said, there hasn't been a new reservoir built in New Jersey since Monksville Reservoir in the early 80s, following a drought right around 1980. We're very fortunate in New Jersey. We haven't had a drought emergency since the year 2002. And subsequent to that, we've had a lot of wet years. Now, is this a sign of natural climate variability, or is there a climate change signal embedded in the wetness we've had in the last 2 decades? We don't know yet. But one thing is for sure, I think we can better deal with a couple degree rise in temperature than the absence of potable water.
Right.
So we have to really be careful. I don't think we're going to see reservoirs built.
No, neither do I.
We need to conserve water better, and we use less water per capita today than we did 40 years ago, because we have water-saving devices, dishwashers, washing machines, shower heads, and things like that. But there's more people here.
It's also a concern of water quality.
Good point.
We live in the most densely populated state in the nation, and it's an urban state. When you have extreme weather events, not as extreme as Sandy, but when you have more torrential rain, the runoff is enormous. that is one of the biggest pathways of pollution to our water, our drinking water systems. And that becomes a problem as to what type of water we are getting from our suppliers, what's coming into our taps. That is always something that, well, that's something that has to be looked at.
If I could jump in on what Scott, what you alluded to and what Dave alluded to also, it's true that the average annual precipitation, it's hard to link that as yet to climate change. But there is one aspect of precipitation, Scott, you mentioned, that is pretty robustly linked to climate change, and that is that the rain that does fall falls in intense events. Mm-hmm. So and it's kind of the basic physics of warmer air. Warmer air can hold more water in the vapor form. So, but when the meteorological conditions are right, that means there's more vapor available to rain. So you get we do see robust trends in like extreme rainfall events. That's true across the U.S.
And that's one of the reasons why we had these algae blooms in New Jersey, is because we had these days of torrential storms, enough rain to put the runoff into our lakes, but not enough to flush the lakes out. So it was followed by maybe a week of sunshine. This is the perfect condition for algae to bloom in a lake, to contaminate a lake, and to pose a threat to the residents around that lake.
And how does algae pose a threat to the residents around the lake?
Well, it's toxic, it's harmful.
Right.
You do not want to be in contact with this algae. It can develop respiratory problems. You do not want to ingest it. And there was a ban on swimming in these lakes and water sports in these lakes. And these lakes are some of the most popular places for residents to go during the summer.
And there's algae in many water bodies, right? But most of the time, it's perfectly fine. It's what a water body is used to. But it's this buildup of nutrients and also things like sediment. The harder the rain falls, the more it scours the landscape. It picks up all the crap that's on the surface.
Often the fertilizer, right?
Yes, and all that fertilizer and all of this stuff is sort of just pours into the water systems. And as a result, the algae has lots of food, and it's very happy, and it grows like wildfire.
And it uses up the oxygen in the lake for other aquatic life.
You'll see fish kills
in
many of these lakes.
Delaware, the Delaware 50 years ago was a terribly noxious river, and it's gotten way cleaner in the last 50 years. 50 years ago, and maybe 100 years ago, there were lots of sturgeon in the river. Mm-hmm. Once it became industrialized, the sturgeon couldn't get through. There was almost like a low oxygen wall between the fish and going upriver to spawn. In the last 10 years or so, the sturgeon have been coming back, but they are an endangered species. The young of sturgeon are not thriving in the Delaware because there is an oxygen sag caused by the wastewater treatment plants. Perfectly legally, some of what they treat doesn't get fully treated. The ammonia goes into the river, steals the oxygen, you have a depletion of oxygen, and the fish can't thrive. It's one of the things that's fascinating to me. I mean, I'm relatively new to environmental reporting, but I think what's fascinating to me, it makes me very excited to see how interconnected it is, and then it makes me very upset because it's so interconnected. When one thing goes wrong, it all goes wrong.
All right. Thank you very much. We have a video from one of our News Lab reporters about the Jersey Shore. Genesis Obando has our story.
Van Houten has lived in Union Beach her whole life. Her family bought this house almost 50 years ago, but in 2012, Hurricane Sandy caused so much damage, the family came together one day and decided to tear the house down.
Like pretty much like our whole entire family came just to say, kind of like, bye. That was a hard day. It was odd because it was like mixed emotions, like you were sad, because that was your childhood. That was the home that your parents brought their children home to.
The U.S. Army Corps of Engineers says that hurricanes like Sandy can become more frequent and destructive in the future. The Corps says there could be damage to the Jersey Shore totaling around $1 billion. Experts say as the Earth gets hotter, ice in the poles begins to melt and sea levels begin to rise. The East Coast is experiencing the highest rates of sea level rise, and because of this, there can be more flooding and storm surges. Hurricanes can become powerful enough to destroy houses and businesses along the shore. These beach towns seem to be trapped in a double whammy situation, with flooding and powerful hurricanes. Ying Sui is a geoscientist and professor at Montclair State University. Sui says that the intensity of hurricanes is caused by warmer temperatures. The warmer it is, the more evaporation there will be. Therefore, more water is being collected by the atmosphere. The more water collected means more rainfall and stronger storms.
Along with the hurricanes, it's not just the higher amount of precipitation, it's also the wind, right, that's brought with the hurricanes.
Like many other residents after Hurricane Sandy, Michael Colombo had to raise his house to avoid flooding from future storms. But he doesn't feel threatened by climate change and the potential damage. Colombo owns the Right Coast Surf Shop in Seaside Park. He's been living there since 1978. He's a surfer, and he says that he hasn't seen much of a difference in the shore.
No, I'm not concerned about it. I really am not. I mean, if it's going to happen, it's going to happen. I'll just know next time to get out of Dodge.
So, can any of these threats to the Jersey Shore be avoided? The Corps suggests storm surge barriers, tide gates, and flood walls for some areas.
So people talk about building, seawalls or levees, right, to protect the infrastructure, or just kind of move people out of the coastal area, right, move them more inland, right? But a lot of people care about their beach properties because, they're valuable and it's a nice location for summer vacations.
These suggested solutions are very expensive and time-consuming for the towns and residents. Jeanette says her house now stands 25 feet taller than it used to. The question now is if raising houses, flood walls, and barriers enough to withstand the threats of climate change? For Montclair News Lab, I'm Genesis Obando.
So we're seeing a terrible effect of more storms, more hurricanes being shown throughout New Jersey with Hurricane Irene, Hurricane Sandy, and more. Why is this happening? Would you mind telling us about that?
Sure. Hurricanes is a big story, of course. Let me make a minor correction, though. There's probably not more storms. If you have to first step back a little bit and look at the entire Atlantic Ocean, and there are many parts of the U.S. that are in harm's way. Obviously, New Jersey is one of them. They're probably not more storms. They're not going to be more storms overall, but the fraction of those storms that reach the highest intensity levels is increasing. So it's a story of not necessarily more overall, but yes, more intense ones. And there's kind of a hierarchy of what we know best about hurricanes and their hazard. The first thing is that even if the statistics of hurricanes don't change, sea level is rising. That's the most robust projection of a changing climate. So we're going to have more storm surge risk. Then you get into issues that there's a strong consensus that the storms are getting stronger, but not necessarily more of them. There are also subtle issues about how the trajectories of the storm tracks are changing, and we know a lot less about that. There's some evidence pointing out that storms may meander and take weird left-hand turns like Sandy did more often. But if you look historically, and this would be true over the entire East Coast, if you look historically at the storms that have done the most damage, it's really a handful of the few intensest storms that do that. And so the fact that the most intense storms are the ones that are increasing rather than all storms overall is alarming, and it's what we should be most worried about.
Yeah, and the thing that worries me about that here in the mid-Atlantic states was born from Sandy. The Hurricane Center thought it would lose its hurricane characteristics off Cape Hatteras and long before it made landfall here in New Jersey. So they changed their forecasting techniques or methodologies, and they since revised them. But we had gone through almost 2 consecutive years of above average temperatures. And with that, the ocean waters were warmer in late October of 2012. And they've actually run models with average ocean temperatures and the actual ocean temperatures at that time. And Sandy took the same track but it was a weaker storm with average sea surface temperatures. So
Yeah,
there's
sure.
evidence of, with warmer ocean waters here in the mid-Atlantic, we may see stronger storms because they'll just persist longer at that
Right. I mean,
higher strength.
Dave's absolutely right. I mean, hurricanes are complicated beasts, but if you want to boil it down to something that's simple and true, and that is that warm seawater is the fuel for hurricanes. And so, other things equal, if the waters are getting warmer, they're going to get stronger, they're going to maintain their intensity as those warm waters push further north in a warming climate. The storms will maintain a higher intensity further north, and you're very possible to get more events like Sandy.
And mind you, on a higher sea level as well.
And one thing that you have to realize with Sandy is that it's not just a coastal event. It's not just a beach event, a Cape May to Sandy Hook type of event. Up here in North Jersey, you had a 9 to 12 foot sea surge that went into Newark Bay, went up the Hackensack River into the Meadowlands and inundated communities like Little Ferry, Moonachie, Teterboro. You had about 2,000 properties that were damaged because of that. So it's not just something that is a problem for one part of the state. It's a problem that is everywhere.
Yeah, and here's another illustration of that. If you go the year before Sandy, Hurricane Irene.
Yeah.
Irene, you can sort of categorize hurricane hazard as there are three forms of hurricanes. They're wind-driven hurricanes, they're surge-driven hurricanes, and then they're rain-driven storms. Irene was a rainstorm. It actually, its worst damage was in upstate New York and Vermont and in western Massachusetts.
Yes. And in New Jersey, it was in the Passaic River Basin, which was inundated with rain and could not handle the amount of water that was falling into the region.
Right, and there have been studies that the average rate you can expect a storm like Sandy, a surge like Sandy, to impact the New York, New Jersey region, just based on increase in sea level alone, just a very sort of middle of the road scenario by mid-century is probably twice as high then as it will be now. And that's only 30 years from now, right? So 30 years from now, you can expect a storm like Sandy twice as frequently.
So this begs the question, how do we get it to not be these big storms? How do we go back to where it used to be, where the storms weren't there? What do we do?
Tackle climate change.
So how do we do that?
Will.
Find a time machine.
No.
Because we're not going to go back there.
We're not, no.
We can ameliorate it.
This is what's called warming in the pipeline. In the unlikely event that we stopped emitting carbon dioxide tomorrow, which is obviously not going to happen, we'll go warming for decades. Simply because the ocean is responding to heating from that blanket of gases from decades ago. It's still responding to what happened decades ago. So there's a certain amount of warming in the oceans that's built into the pipeline for several decades out.
So we actually have a student question that we taped before the show, so let's take a listen to that.
My question is, would it be worth buying beachfront property if experts are saying it is going to flood?
I'll let anyone answer that that wants to.
How long do you want to live there? No, I'm serious. We're going to be battling this for the next couple of generations until probably sea level is going to rise too high to do anything about it. And in the meantime, there's going to be quite a battle. And New Jersey coast is going to be at the forefront of that battle because we have such ratables there. And culturally, it's such an important part of our psyche that we're going to battle it as long as we can. So, in the short term, go to the shore, enjoy the shore, but appreciate that there is change underway, not coming, but underway. That's only going to get worse in the future.
And one of the things that again, my focus is mostly on the Delaware River. I focus a lot on what I call Jersey's other shore, the southern shore. There's an enormous amount of property damage and enormous, as you said, ratables all along the Atlantic coast. When you go to Jersey's other shore, which is basically Cape May and then following the Delaware up, you get this story in a very different way. Houses are being abandoned because of the impact of storm. Sometimes the storm takes the house away, sometimes it just damages it. A lot of times communities are dying because their septic systems are ruined. Because when the sea level comes in, the seawater comes in and rises, their septic tanks can't do their job. I spoke to a woman who had a house in one of those communities, it's Gandy's, that she was at that time and has now moved because when the tides were wrong, she either couldn't get to her kids to pick them up from the school bus because of the flooding, or she had to wait with the kids in the car until the floods went away to get back to our house.
So with those damages, who's responsible for paying for those damages? Is it the person that owns the property, or is it the local government or the state government?
Well,
I think
if you have
in many cases,
insurance,
insurance is the first
if you
line
have
of
flood insurance, then you will have some coverage for sure. But a lot of people don't have flood insurance, though they probably should. It's not that deeply penetrated as you might expect into the housing market. And another thing related to insurance, said a lot of homeowners may not realize this too, but their homeowners policy renews every year. And I've often wondered whether that is a sort of, it creates a lack of incentive to look at the long-term trends. I often wondered if you had a homeowner's policy, if the insurance companies had policies that were, say, a decade or something, if the policies, you have to have a policy to get a mortgage, so, insurance is incredibly important, but if you couldn't get one or it was more expensive because it was looking out a decade, that might be a sort of a private sector incentive to not be building properties that are sitting right on the beach and that are prone to being destroyed by storm surge.
It's odd that we're just talking about this, and society is kind of grappling with this over the last, several years, decades or so. I learned of the greenhouse effect, as we called it, in 1986 in my earth science class in elementary school. Mr. Fishbein, thank you very much. We learned it as fact then. Didn't know as much as we do now, didn't call it climate change or global warming, at least not in my class, but we knew that there were greenhouse gases going into the atmosphere that were creating this blanket effect, trapping heat in the earth, not having it escape to space. And really only now are we confronting what's happening.
The greenhouse effect is, we're happy to have a greenhouse effect in some level, because if we didn't have a greenhouse effect, the Earth would be a frozen wasteland. So, but the change in the greenhouse effect is, the thing is that civilization built up over 10,000 years in a relatively stable climate. So they built these cities near the coast, and they built these farms in places that were rich and fertile. And now suddenly the climate's changing really rapidly. And it's not clear that civilization can respond that rapidly.
Ms. McGuire, what do you think about that?
What do I think about that? I think that, like we were actually talking in the green room about this, the odd place that we've come to where beliefs argue with science.
Right.
And it's not all beliefs, and it doesn't argue with all science. Like nanotechnology, everyone's all whiz bang, that's great, right? But when it comes to climate change, we want to argue with the science. And it's just a funny cultural moment that science somehow can't convince people. And it's, you're right. We've known about this for 86, that's, how many years is that? 25. A lot.
And the physics has been known since the 1800s, just
Absolutely.
basic thermodynamics and things you learn in high school physics.
But there is a preference to not believe, which is just extraordinary. And the thing is, perhaps 10, 20 years ago, I think some of the fossil fuel companies did fund some of the climate change denial stuff that was going on. Now, those companies are like all on board with climate change, and they're trying to pretend that they are, helping.
Right.
Whatever. Not sure. But I think it's such a cultural problem that facts do not stand up in the face of people's beliefs.
And that begs the question, what is the motivation behind climate change deniers?
To play off that, I think it's certainly cultural. I think there is a bit of a red state, blue state, coastal elite versus everyone else, that we should be skeptical of everything that's said and told to us. Whenever I write a climate change story, I get more emails of angry readers than any other subject I write about. And it could be just a very innocuous story. It doesn't have to be something that's in depth or anything. But the minute that someone sees that, they're shooting off an email to me.
Do we think that people are just stuck in their ways and don't want to change their lifestyle to try to reverse or even slightly reverse the effects of climate change?
That's part of it. There's people are just born skeptics, and scientists are skeptics themselves,
Sure.
I might add. But it's political, it's cultural, it can be religious, it can be economic, but generally these days, if you boil it down, it's a political issue. People who align with parties that's where you find a dividing line, and there have been studies of late that have shown that. I like to think of it as a little more complex and complicated for that, but really just the recent studies boil down to the fact that it's kind of your political leaning is going to dictate your thoughts on climate change.
But it's really, it really comes down to evidence. And the evidence is there. There's a preponderance of evidence. And I said this also in the green room. If ever somebody is on the fence about this, I always tell them, go with the guys who got us to the moon, because NASA has some of the best research in the world on climate change. A plug for you, yes. But it is. And they also have a website that tells it and explains it to the layperson in very, very easy terms, doesn't dumb it down, but explains the who, what, why, when, and also the consequences, where we're going with this. It's a great site. I recommend it to anyone.
So in a world that everyone believed and understood the facts that climate change is a real thing, what is the next step? Dr. Robinson?
Yeah, that's where it gets more complicated because, first I want everybody to understand what's going on. Then if we can agree that there's change occurring and why it is occurring, then we can delve into the societal implications of this and what do we do in terms of adaptive practices and mitigative practices. And it's going to be a combination of both. Right. And that's when the discussion gets real interesting, where you talk about carbon tax or carbon credits, or you go and talk about clean energy and the wind farms along the coast. There's so much to discuss. And that's what I'd like to see the dialogue be right now. And just everyone get over the fact that, there is change occurring and understand why. So the door is wide open for a widespread debate and a lot of different ways of going and addressing this issue.
And it should speak to the sort of the American engine, the ingenuity, the multiplicity of responses to different problems. It is a classic American problem to solve. But for right now, we have this wall that's dividing us from each other and from our hopeful future.
And I think also there's a bit of our natural ingenuity wants to think that there's one single solution that's going to solve the whole thing. And I think an alternative way to think about it is kind of bending the curve down, like reducing emissions into the atmosphere, and each little bit we can reduce, sort of lowers the odds of a truly catastrophic future. And those are done by different pieces. They're done by renewable energy, more relying on that, or encouraging that through a carbon tax. They're done by, energy efficiency issues, maybe more efficient grids. And then, so each little bit can bend the curve down. And there's not going to be one single magic bullet. But at the same time, as Dave pointed out, because there's warming in the pipeline, we also have to adapt. We have to admit that it's going to go on warming for several decades no matter what we do, and possibly much longer than that, likely much longer than that. So that involves, enjoy the coast while you can, but I mean, ultimately there's going to be some population retreat from the coastline when it just becomes uninhabitable. That's actually already happening in other states. In the Mississippi Delta region in Louisiana, I mean, towns are retreating from areas that are just, access to those towns are underwater half the year. I mean, basically, that's happening.
And I might add, as we're the scientists sitting here, but we have two communicators in journalism, and as scientists, many of us have to step up and talk about this and learn how to communicate. And we can learn a lot from journalists.
We depend.
Those sitting around here.
I depend on folks like Dave and Tim. I'm not a scientist. But
you play one on TV.
Sometimes I do. Tonight, maybe. But I depend on their research enormously. And whether it's one research paper that comes out that propels the science along, whether it's preponderance of research that propels it along, it's important. And there are tons of scientists in this state that are doing great research, from Rutgers to Stockton to Monmouth. Great work on climate change.
A question for the two of you. A lot of people want to know more about climate change, but sometimes they don't know what's the most reputable news source. How do they figure that out?
Oh, of course, it's NorthJersey.com. USA Today Network.
No, it's NASA.
It's also NASA, yes.
What are some key things that we can look for in news networks to realize whether they're reputable or not?
I think sensationalism is always something that it kind of throws everything off, and sometimes with climate it can be sensationalized by certain outlets. The facts are the facts. The projections may change here and there, but you see that it's pointing in one direction. So I would go with look. The New York Times has about a 6-team climate desk, maybe even more than that. Reporters just honed in on that one. There's certain news sites that are devoted only to climate change. Climate Central is one of them. They're excellent at distilling what the scientists say and showing what the impact would be to everyone.
Yeah, and I also think they're probably really good at not focusing too much on the absolute single latest study, but rather kind of integrating over a couple of years worth of studies so that are all pointing in the same direction. I mean, sometimes you see one study and you think, oh, it's pretty rare that one single study absolutely changes the direction of a field. You know, and of course, you know, we as scientists like to hype our most recent study. It's human nature, but really you need to sort of look at sort of a bunch of studies over a period of time. I mean, one of the international, also national agencies that does that is nationally, it's the National Climate Assessment, which comes out every 4 years. I mean, it's probably a tough read for the average lay person, but a place like Climate Central would probably, you know, do a lot of the reporting based on that kind of already filtered analysis of individual scientific studies.
And, you know, the thing that, again, we were talking about previously from my perspective, even like 10 years ago, local newsrooms were more robust and there were more local environmental reporters. So there was more people like Scott reporting to his community about what the impacts of climate change and being there on the ground showing people the facts, right? The fewer environmental reporters you have, and as newsrooms shrink, there are fewer environmental reporters. There's less on the ground, local things that I can touch and I can understand. That farm used to be where I bought my apples. Now that farm doesn't exist anymore.
Right.
That's a thing that people can understand. And I think that what then ends up happening, we end up, it's not a bad thing really, but we look at the issue of climate change on the national level. And then that can get into a lot of vague stuff that's not concrete, that is arguable, that is whatever. But it's this idea, if you have local reporters reporting on a concrete event in a local community, it makes a world of difference.
Thank you all for that. And we have one last student question, so let's take a listen.
My question is, when they talk about having a limited time to reverse our actions before the world ends, what exactly do they mean?
Dr. Robinson, you're laughing. Would you mind starting?
The world is not going to end. It's going to be more difficult in some respects, and we may have to change certain ways that we live and where we live. But, you know, our ingenuity kind of got us into this mess. We were very successful as society in developing. So I'd like to think that since we got ourselves into this mess with some smart people out there, we might be able to apply that to getting out of it a little bit. So it's not Armageddon, but it is going to be a problem throughout the remainder of everyone's lives that are sitting on Earth today and are going to come forward in the decades ahead.
Thank you. Mr. Fallon?
Ditto. I mean, Dave summed it up perfectly. I think this is something that we will be adapting to, something that we will have to adapt to. There's no denying it. There's no way around it.
But I would just add to it, I agree civilization is not absolutely going to end, but the more we can bend that curve down, the better off we are. Because even right now, there are environmental refugees and refugees due to climate change, and there will be more of them, and there's going to be a lot of human suffering. So civilization is not going to end, but there's going to be a lot of suffering. And we can alleviate quite a bit of that suffering by our actions now, by bending the emissions curve down, by taking actions about how we develop urban centers, coastal centers that accommodate the fact that things aren't stationary. They're not just static. They're evolving. Sea level's rising, temperatures are increasing, so we have to adapt to that.
Yeah, one of the things that I think of, and I'm apologizing to people who are 30 and younger, apologizing to them for what we have done to the world. And I don't think that people who are now in power have owned up to our responsibility for how we have damaged the world and the responsibility we have to change it for the future.
And we have to understand that what we do and don't do today is going to have perhaps greater ramifications in the second half of this century than it will have for the next 20 years. Yeah. Well, that table's already kind of set.
That's a tough thing for humans. But beyond 2050, and it's tough for humans, it's especially tough for politicians to understand that. And that is something I think we're going to continue wrestling with and having to communicate with everyone to get on board.
Sorry, Mr. Fallon, would you like to add anything to that?
Absolutely. We as Dave said, we are a very immediate culture, and thinking long term is very difficult for us, very difficult for markets, for politicians, for the average Joe. But it's something you have to do. Climate change is here. It's been here for a while, and it will be a part of our lives and our children's lives and our grandchildren's lives.
Mm-hmm.
So, one last question. Are we fighting a lost cause? Do we think that there's any way that we can get out of this eventually? We see hundreds of years from now.
I think your idea that you've been presenting of sort of bending the curve, it's really a question that we have the capacity to bend that curve. We just have to have the will. Mm-hmm. And I think the worse ramifications we see around us, the more will there will be to bend that curve. But the thing is it going to bend the curve when it's up here, or is it going to bend the curve when it's down here? And that's the story of the coming decades. Yeah. When will we develop the will to do what needs to be done in order to make the world safe for everyone who lives in it?
And I add to that in terms of carbon dioxide loading in the atmosphere, which comes mostly from fossil fuel combustion. We are going to run out at some point of cheaply extractable fossil fuels. I mean, people can debate whether that's a decade or two off or 50 years off or happening now. But, wouldn't it be nice if we can just we're going to run out of it anyway, so wouldn't it be nice if we can just keep from dumping what's left into the atmosphere and, and do something that we're going to have to do anyway down the road, and we could, in the meantime, alleviate a lot of human suffering.
Sure. Dr. Robinson, anything else?
Well, I just don't think it's lost. I think it would be foolish to give up on that. Again, I get back to the ingenuity of the human species and our ability to solve problems and adapt where necessary. But it is going to be, as Scott said, it's going to be a tough road to hoe for ourselves, but more than that, for generations ahead. And I'm not going to sit here and apologize all night about it. But, and one thing we haven't addressed is also, we've talked about it as United States issue, but some of the feedback I'll get sometimes is, well, we're not the only cause of it. Yeah, proportionate to our population we are. But this is an international, this is a global issue, and it's going to take partnerships globally. It's not just U.S. created problem, nor is it a problem that U.S. can solve by itself.
Right.
All right. Thank you, everyone. That's all the time we have tonight. I really appreciate the time that you took to come here to Montclair State University, give us some answers, and contribute to our conversation.
I would also like to thank those of you watching across the state. We hope you have learned about how climate change is affecting New Jersey. From the School of Communication and Media here at Montclair State University, I'm Louis Biontalillo. Have a good night.